Hey everyone, thank you so much for watching the Weaviate Podcast. I'm super excited to welcome the co-authors of the Gorilla large language model, Shishir and Tianjun. This is one of the most exciting large language models out there. I think it's so cool how this enables large language models for tool use and all sorts of exciting topics. So before diving into it, Shishir and Tianjun, thank you so much for joining the Weaviate Podcast.
Yeah, thank you so much for having us, Connor. Appreciate it and looking forward to it.
Awesome. So could we kick this off with kind of like this LLMs for tool use, kind of like treating tool use and properly formatting API calls as kind of like a new task in deep learning, this vision of Gorilla being the API app store for LLMs. I think it's such a compelling vision. Could you kind of, tell the story of Gorilla?
Yeah, for sure. So I think the start of sometime around the end of last year, maybe November, December 2022, when there was ChatGPT was the rage and a lot of people were trying it, including us. And as some early adopters, what we soon realized was that a lot of these tools, at least from a chatting modality, was good to maybe as a demonstration of the technology of what LLMs can do, but we felt that probably this is not what the future would look like, right? In our minds, an LLM is a powerful tool, powerful nonetheless, but still a tool, right? And then now you need to have tools, need to interact with other tools to get more stuff done. And in computer science, the way different tools interact with each other is through API calls. And so that was the germ of the idea where we were like, hey, this is a tool. This needs to talk to other APIs, and that's how we got started. So this was like the original or the story of the origins of Gorilla.
Yeah, amazing. I love that like the video demo you have where you show like how it can use a CLI. Like you have this example where in natural language you ask, I want to download the Gorilla dataset from an S3 bucket, and all those API requests, all that intermediate orchestration is handled by this model. And Tianjin, I remember when we met at Berkeley, you showed me this like GitHub CLI and how it can format the GitHub CLI request. Could maybe talk a little more about the particular kind of APIs that you two have started to explore using Gorilla for?
Yeah, so we have been initially, because as a PhD student and also machine learning researchers, for the paper side, we choose HuggingFace models and also TensorFlow and also TorchHub. So those models are pretty particular for machine learning audience. And usually the case is like they want to know actually some model they use for image classification, but not exactly what model they want. They may also have some specific requirements for especially the model size. I want a smaller model under 10 million parameters, or I want specifically resonant family, or what, so on and so forth. So that's also some constraint. That's for the paper side. And afterwards, we're kind of moving towards think about how people in general are having a pretty, it's just having not very good particular sense of what the exact API to use. They kind of sort of remember something, as also we discussed a little bit with Shishir, and especially for this GitHub stuff, right? You want to know if I want to check out some of the project base last Friday, you sort of knows the command basically, roughly, but not the exact command. Also something like Kubernetes, AWS. So that has been our focus for the second wave, especially in terms of the Gorilla CRI. We have been working on the Linux command line, GitHub, and AWS Azure, also the GCP, Kubernetes. That's kind of the supports we are having from there.
Yeah, that's really, I mean, I love that so much. I think all the time I have like, I might have like a picture of this podcast thumbnail and I'd be like, could you make a pull request to the Weaviate.io website to add this to the podcast? And it's like that the little bit of doing the new branch and then putting it in that part, it's like a bit of overhead that this Gorilla model, I think, can just simplify that dramatically. And I think, I really want to dive into kind of using Gorilla for the Weaviate APIs, but I guess kind of I want to take apart a little like in the Gorilla paper, you have the Torch Hub, Tensor Hub, Hugging Face. As you mentioned, you specify kind of like what model you want to use, and it has constraints like, I need a 85% plus ImageNet accuracy ResNet, but please make it like less than 20 million parameters so I don't have to like break my bank serving this. And then there's kind of like the APIs like, GitHub, Kubernetes, you mentioned like can you tell me how you see like APIs for, Kubernetes, GitHub, and cloud storage downloads, and then kind of model inference, like picking the right model from Hugging Face?
Yeah, so I think like it's tricky and it's similar in different ways, right? So one example is if you look at the machine learning space of APIs that we serve through Gorilla, a lot of times, like for one task, you have so many different models that are doing almost the same thing but slightly different, right? So it's like, oh, I have an object detection model. One could be for animals and the other could be for plants, say, for example. Or it could be like different models, like almost the same thing. One uses the ResNet 18 backbone, the other one uses the ResNet 50 backbone, as another example. So the fact that they're so similar and we are still able to like discern between the different APIs is actually pretty interesting, right? Because that's the challenging part. If I ask you to differentiate between a Stripe payment API and say a GCP API, it's easy to do in some sense, like very different domains, diverse functionalities, different modalities. But to say, hey, look, from the two very similar APIs, can you now differentiate and satisfy the constraints that I give you? And that's quite tricky and challenging, right? So that's why that's also what makes the initial API bench that we have quite tricky, because you're trying to like tease apart these differences among the different APIs that exist. Now, on the other side of it, like Tianjun mentioned, it's not every day that you go and ask, oh, how do I do a text to speech, right? But on the other hand, as researchers and a lot of people very often tend to use all the APIs that Tianjun mentioned. So in those scenarios, it's like very, very different use cases. Like one is more practical, more useful, and like looking ahead, like this was more like from a daily UNI developer or like a common user perspective. But the good thing is we have like this Discord community where we get a lot of feedback and a lot of users using it. And so now the new thing that we learned is that, oh, like people are interested in Salesforce and like ServiceNow and like all of these APIs and like the Open API spec and stuff like that. So now we're like trying to like train models with these new APIs and add that into the Gorilla ecosystem as well.
Yeah, I love what you've done with this like API zoo, this vision. I see a lot of the thumbnails, like YouTube video. There's quite a lot of reaction to Gorilla, and I think that kind of API app store for LLMs is the thing that like the headline that people are loving. So yeah, so people, you're starting from the model APIs, and I think there's quite a lot of interesting things that you've done with like the abstract syntax tree for how you evaluate if you formatted that particular request correctly. But I guess I just want to kind of maybe even stay on this just for our listeners to say like this API zoo, you're building up a big data set of different APIs, whether it's Kubernetes or GitHub CLI. How do you see that kind of API zoo evolving?
Yeah, so Connor, the other interesting point is that a paper is a snapshot in time, whereas the open source project evolves almost daily, right? And we had this at the back of our mind even when we started off, which was like, look, but at the same time, you want something that's set in stone to benchmark against, because if you have a moving target, then how do you know how well you're performing, etc. So this was a thought process where you would have like the API bench, which we released as a part of the paper. This would be like one yardstick that you can use to measure, all the different models that come out, and that's why we have tried to make it as easy as possible. We put out the evaluation scripts, and we have all the eval split neat and clean, so people can try the different models, benchmark it, etc. And this would evolve much slowly, right? On the other hand, what we also learned is that there's way more APIs than what you, Tianjun, and me, or the three of us could do, or even like a small subset of people can do. So the idea was that people can contribute their own APIs, and then we can now use this, train the model, and then serve many other people. And one thing that's critical is that unlike there's been like a lot of legal questions around can you scrape this, scrape that, etc. Is it okay to like for an LLM to learn this data and serve it? APIs are meant to be distributed. Like the more people use a particular API, the more inbound it is for the people whose APIs people are being used, right? People whose APIs are being used, right? So in some sense, like this is the incentives are purely aligned, right? Like in fact, people actually put out documentation, tutorials, Swagger documents that other people can use to actually use their APIs and build on top of it. So this was the idea, and there's been like a lot of interest in like, oh, how can we contribute our APIs into the API zoo? because then we can train the model, and then many other people can use this model to then get their work done with a very small or like very quick ramp up period.
Yeah, I just want to add a little bit. Also, another point like this APIs, like people are building APIs every day. There are new APIs, or maybe even changing the API versions. And then like this is not a one time shot timestamp like static data set. It's like meant to be dynamic, and people can building their new APIs. People can update their versions of APIs or even the usage of the APIs. So that's also another interesting question we want to study by empowering this APIZoo, because people are now freely to update, and then we can also study how the language model can to the best support this dynamic change of the APIs.
Yeah, so it's super interesting. I think kind of quickly before we go further into the training of the LLMs, the Gorilla LLMs, let's kind of differentiate between this Gorilla LLMs and like the OpenAI funks with the JSON, where you kind of give it like this JSON dictionary of how to format the arguments. Like obviously it's like zero shot versus fine tune, but maybe like do you have any thoughts on like what the limitations of that kind of OpenAI funks approach might be compared to this kind of train an LLM specifically for data for the APIs?
Yeah, that's a great question. And I think the way I think of OpenAI functions is that you know what API to call. You just want to fill in the arguments into that API, and you get the response, right? And Connor, there's also very similar to what they did with plugins in the ChatGPT scenario, where you go and pick a few plugins that you want, and then to given a question, it would answer. What we're trying to address is the step zero, which is API discovery, right? Like we have a friend who's trying to build an app, and now he wants to integrate payment processing into that. Well, Stripe has a bunch of APIs, and there's like a bunch of other people with different APIs. Which one do you even call? Right? Like, how do you do the discovery? And in many scenarios, you don't even know what's a good discovery mechanism, right? Like, if you want a good database on your for a React app that you have on your iPhone, what do you use? If you're in the domain, then yes, probably you know what your colleagues are using, but otherwise, how do you know? So it's like API discovery is something that's I think is an open problem that we're trying to solve with Gorilla, which is that you go with an intent, and then can you get the right API? And it's even better where if you can also like fill in the right documents itself, and then you just get that as in a single attempt kind of thing.
Yeah, that vision is incredibly compelling to me, and especially like as we step into the details of how you train these Gorilla LLMs, this kind of retrieval-aware training. You say API discovery. How do I find the right API? I take a natural command like, "Hey, I want to add a secure payment processing in a JavaScript interface, something like this," and then you retrieve from this database to get the API. Can we kind of step into the details like how you're seeing this retrieval-aware training?
Yeah, so we see this retrieval-aware training is actually slightly different from just the fine. So in the paper, we have two versions we compare to. One is purely zero shot. Basically, we don't do any information retrieving. But one of the bottleneck for this is, as most of the language models are still, they are also having today, is like they cannot keep their knowledge up to date. If I ask anything that is happened later than their training dataset end date, they have no clue what's going on here. Although there are a lot of other studies like retriever-aware generation or different various of retrievers, basically enabling Google search and other for various source of informations to connect between this up-to-date information and also the language model itself. But what we think the retrieval-aware training is like the beauty of that lies mostly in you can actually read your documentations. Like the documentations can be updated like daily or even daily or weekly, right? It's much lower the frequency you would want to train your large 70 billion language model or 170 billion language model. So we want to actually train the model to read these documentations and actually figuring out how you can from these documentations write the corresponding APIs. And then the users or the developers can update their documentations every day or giving it new function names or even update their versions. And this kind of is what we see also sort of missing in the current language model scenarios, because we have actually identified a couple of papers saying that if you put a bunch of the retrieving results and some of them are incorrect or some of them are irrelevant, this would definitely dramatically hurt the current language model's performance, even in GPT-4. So that's the part we actually want to dive into and try to solve using the retriever-aware training, that part of the concept.
Yeah, and you can think of the key insight with an example, right? So, for example, you say, "Look, I want to classify an image, and then if I and you'd use a retriever and then augment your prompt with what the retriever gave you. So the retriever told you, hey, why don't you use this, like a vision transformer backbone? Then you're like, well, okay, this is relevant information. I'm going to use this. This if the retriever is correct. But if the retriever is wrong and it says, oh, you want to classify this image, excuse me, why don't you use this text to speech API? Then in some sense what we train the model to do is to actually ignore that, to say, hey, look, recognize that the retriever can be wrong. So I'm first going to determine if the retriever is correct or wrong. If it's correct, then I'm going to use that API. If it's wrong, then I'm going to discard that retrieved API and instead rely upon my knowledge base to then generate the right call for this particular task. So there's like this high level 1 bit information. Should I use this information or should I discard this information? Is what we're trying to teach the LLM, which I think is pretty critical because retrievers are never accurate, right? We all know that. Uh,
Yeah, I mean, it's like kind of especially in our world of Weaviate, we think a lot about like RAG pipelines and what that like you might like your retrieval might be like BM25 and vector search, hybrid search, some weighting, especially if it's like how do I use the pipe API, like how do I use the hybrid search API that those keyword matches, I imagine, especially for this application. But then you have, say, maybe you want to re-rank with a cross encoder the top results, or as you mentioned, like you could have something where you pass in the query in a candidate document to the LLM and just ask it, is this relevant? Please say yes or no. And if no, throw it out. And there's definitely so many interesting ideas there, which is exactly what I want. One thing I wanted to ask you is this kind of like, there was this paper called Lost in the Middle, which is about how you can't really just fix it by retrieving a lot to put into the language model, right? So like, are you thinking about trying to just put one API in the, hopefully the perfect API reference, right? The one API, or do you maybe have some K APIs to put in that input window?
Right. So I think so in our at least in our evaluations and numbers, so this is like basically recall at k, right? And we were like, hey, let's look at recall at k where k equals 1 because we're not trying to like in some sense rank the retrievers, etc. And that's also why like we do comparison with BM25, which is a popular retriever, and then one that uses like some GPT embeddings to compare, which today most people consider to be pretty good, if not the state of the art. And we also have an Oracle retriever, right? So like if God gave you the correct API, then how well can you do? And the idea is because with this, we're trying to just demonstrate that look, there's going to be some noise in the process. What we want is to so there is a community that's trying to like reduce noise, right? I'm sure for VBA, this would be come in terms of how well can you improve your recall at K. But in those scenarios where you have this long tail, where you still cannot fit this because the queries are under spec, etc. In those scenarios, can we like make the model itself robust? Now go ahead and tackle this. So if you make a better retriever, you benefit from it. And in those scenarios where the retriever falls short, you can still determine what's the right analysis is and get the result of the user.
Yeah, and also if this is like for one of the if you determine your task or you know for sure your task only requires one API, but often in the case your task requires like stacking together, or it's a mixture of multiple APIs. Let's say like 5 to 10 APIs, and then in this case, you would definitely need more information in your retrieving process. There are, I think, definitely a lot of other various of retrieving process you can add to make this process more accurate. But often the times is like it's going to be a little bit tricky to or even harder to deal with when you're actually your context of APIs requiring multiple documents or multiple APIs.
That's amazing. I mean, I this mixing APIs thing is what that's what blows my mind more than anything else, is to have a natural language command where I'd say, could you build me like an index of archive papers using Weaviate and Llama Index, and Gorilla does every single thing in the middle of that, calling the Weaviate APIs as well as the Llama Index APIs as well as maybe these archive data downloader APIs. Yeah, I love that. And something else is kind of like there's this thing about like like with search, you typically try to optimize throughput and optimize latency to make it as fast as possible, because most of the time you're thinking about like web search or like e-commerce. But I think with applications like this, I think that latency constraint kind of eases off, and it's way more important to re-rank and make sure you have that top, that top one is really great. Do you kind of agree with that opinion, that latency, maybe that this is a good example of one of those tasks where you would be willing to tolerate a slower response if more accurate?
Yeah, Connor, this is critical for two reasons, right? One is what you just mentioned, which is lost in the middle kind of stuff, where it's been shown that if you have too many contexts, then you tend to lose a lot of information that's in between, and retain the ones that's at the front or the back. So in our case, in terms of APIs, if you were to like give 10 different APIs, then a lot of things that's in between gets lost. Uh, so that's one. And the second is, and this is informed from the downstream task, right? Like when you do search today, and if the search result shows you 10 different uh, links, then the burden of proof is on the user to pick the right link and follow it downstream. Whereas in the case of like a lot of these LLMs, where if you want to like chain these APIs together, then in some sense, like you are going to pick the best API that comes out. So basically, the top one is roughly what matters, and then you're going to like pursue that and then proceed with the rest of your steps. Right now, suppose the top one is wrong and you have like an fail early kind of mechanism. That's good because at least you get a signal and then you can like go cycle through the remaining. But what if it's like it's not wrong but it's inaccurate, right? Or what if it doesn't fail but then it continues on like some long loop that keeps regressing? So that's bad, right? Because now you're just wasting time and resources without really getting closer to your result slash answer than you were before. So I think for these two scenarios, especially as we try to automate more and more stuff, it becomes critical that you get it right in, in the first attempt.
Yeah, and I think just using one API by itself can be extremely powerful, like just the GitHub CLI, Kubernetes you mentioned. But this kind of like combine archive with Weaviate with Llama Index is super compelling. And so I wonder about the kind of the system architecture. Like, does GPT-4, or like the most powerful cut capable like diversely reasoning ability the LLM, does that kind of orchestrate the intermediate calls to say like archive gorilla, Weaviate gorilla, llama gorilla, or even just the same gorilla model for all three, all train on everything in the API zoo? So this kind of like, would you still use some other language model to kind of orchestrate the steps and have almost like a chain of thought, like the kind of do this, then this, then this?
Yeah, I think we are actually not um, tied to either one of this. I mean, we could imagine in one case is if you want a really complex task. The task involves a lot of reasoning and involves a lot of tool, like basically like breaking down tasks into a lot of subtasks, and this involves a lot of reasoning. Then we could imagine like at least I'm not aware of any of the current open source model that can really achieve very good performance as well as GPT-4 or even GPT 3.5 like ChatGPT. So this is like one of the unique benefits of even you do chain of thought. Like this is a unique benefit of reasoning capabilities in there. So I would say, if imagine like the task is really hard and you need a lot of reasoning steps, chain of thought steps, then probably the best usage is you take the most powerful model up to date, like GPT-4, breaking this down into some sub small steps, and then you could call another internal like Gorilla, for example, that can give you very reliable and accurate tool usage or APIs for these small steps, and then you could chain them together afterwards. But I would imagine also for some relatively easier tasks that involves only maybe two or three or a couple more steps, of training APIs, then actually smaller model maybe can handle this well. I mean, we don't have any results for today up to now, but I believe we could, as also the open source models progress, we could do better and better in these domains as well.
Yeah, I'd love to hop in on that. So let's get into it. I mean, I think like the 15 billion parameter is currently the state of the art LLM at text to SQL, and SQL I think is a pretty tough API for this, right? Like that might be like the goalpost for all this. But so let's talk about kind of self-instruct curation of training data. Like how do can Llama 7B be trained to write Weaviate queries better than GPT-4, and how does this work?
Yes, the answer to your second question is yes, 100%, and that's also what we show in the paper. Uh, and obviously, like having a specific domain gives us the benefit. But the pipeline is the following, right? So you have the documentation, and a lot of the times this might come in pretty diverse formats and how these documentations are, right? So what we have is a pipeline for training where we take all of these documentations, and the first thing that we do is like we create a pretty dense representation of all of this information. And this is human readable. I think of it as a JSON format. But JSONs are pretty hard, especially if you have code involved, new lines, and I mean it's doable, but it might be hard to maintain consistently. So we have like small unique flags that we use, and by the way, also is open sourced in our repository. So then we create like these dense representations of all the data we have, and this includes stuff like, oh, here's how the performance metrics are, or like here's the latency numbers, here's throughput, here's the accuracy, etc. for each of these APIs. um, in terms of Weaviate or like any of Llama Index, it would be like, oh, here's the authentication that's required, etc., etc. And once we have this serves us two purposes now. One is I can use this to now generate some self-instruct API pairs. And for that, you would use like any general purpose LLM that doesn't necessarily have to be good at APIs, but it has some language understanding that it can, like, read some APIs and come up with potential user-based questions. And we found that it's pretty good if we seed this with some in-context examples ourselves. So we create six. I mean, there's no reason it has to be six, but we have like six instruction API pairs from which we sample three stochastically for every generation. So we give these three as, in context learning and say, hey, you've seen these three instruction API pairs. Now, given this new API, can you please come up with an instruction that would be a good pair to this? So this is how like you can generate self-instruct API pairs, but also this dense API representation now goes into our API zoo, which we can then use in the retrieval phase, in the inference phase for the retrieval aware generations, right? So that's how we use this. And once you have the self-instruct, then you would then go ahead and you would train the model. And for training the model, we use what I said is RAT, the Retrieval-Aware Training, which is pretty critical in getting accurate numbers, even when the retrievers may or may not give you the exact value. So this is the training phase. In the inference phase, there are two ways. One is where the user asks a question, a prompt, then you find the most relevant top K documents, which would be APIs in this case. You find the top K most relevant APIs, give this together to the Gorilla LLM, and then Gorilla will come up with a response that you can just execute the code and get the response. But there's also another way, and this is the most popular among our open source community, which is a zero shot approach. You ask a question directly to the LLM, and it comes up with an API from what it knows that can help you answer the question.
I think even just kind of the retrieval database of APIs for the zero shot is useful as well. But yeah, so kind of to talk a little bit about my perspective on adding this to Weaviate and building Weaviate Gorilla, what I've been doing is, I have a data set of each of the Weaviate search APIs, and then I loop through toy schemas and I, generate it for each of the schemas, and then that becomes the training data. And I guess the big question that I'm so curious of your perspective on is like, so I am kind of validating these queries and so on, and I'm curious if you think like if Gorilla will be one model, or if like Weaviate, Llama Index, say Rise AI, Unstructured, LangChain, like all these companies maintain their own Gorilla, and then they kind of and then Gorilla, there's like Gorilla Hub where I put my gorilla, a Weaviate gorilla into to then when you say, hey, could you get archive, put it into Weaviate, put it into a Llama Index query router, maybe visualize it with a Rise AI, or like like do you think everyone will maintain their own gorilla?
Yeah, for real. Okay, before that, Conor, I want to really appreciate how quickly you guys were able to turn around and build your own Gorilla. Because I remember we just chatted, I think less than a month ago, and then you were like, "Oh, what's this going on?" And then the next time you pinged me, it was like, "Oh, we have all of this ready." So it was pretty, yeah, tough job with that. Uh,
Well, if I can butt in quickly, I mean, this has completely changed my perspective on how companies can train LLMs for their custom tasks. Like, yeah, and yeah, I mean, thanks for that. Because I love this idea. It's so cool. Yeah.
yeah, thanks, Connor. And yeah, that's a good question. And so when we started out, right, initially our idea was that, look, we're gonna have maybe one or like a few models that's gonna serve most APIs, and then when the user comes, we give them the APIs. But increasingly, I think or at least I've started to think, believe what you mentioned, which is they're gonna have also with multiple baby gorillas. And this came about from yeah, this came about from two interactions we had. One is we're part of a PhD lab where we like, like we have a retreat where we like give presentations and a lot of our sponsors and people who are interested come in and they hear. And in one such retreat where we were discussing gorilla, some institutions came up to us and said, "Hey, can we have a gorilla trained for our own private APIs?" And so initially I was like, well, why would you do that? That's slightly counterintuitive. But then we realized that the way, they were like, look, we have multiple divisions within our enterprise, and each of them have some are API producers, some are API consumers, but they don't talk very much, or like there's no free flow of information. It's even within an enterprise. It's quite possible that your customer success engineers are not aware of all the APIs that your engineering team is coming up with. So then in this scenario, like you would have Gorilla just serve internal APIs to different teams within the same institution, right?
That also just changed my because you could do this with all of the functions and all of the classes in a code base, right? Like how you want to like if I'm saying with Weaviate, if I'm like, hey, I want to implement scan quantization or whatever, and it's like you have to go interface with like how Weaviate's going to do that, how it combines the database with the quantization scheduling and all this. So yeah, I mean it's it's funny to think about, but yeah.
Yeah, and the second one is what you mentioned, which is like at Weaviate, there's a new person who comes in, and they're like they know how to use all the other tools very well, but not the new APIs in that scenario. Then you can be like, hey, you want to use Weaviate? Here's a smooth onboarding experience for you, where you can just talk to Gorilla natural language. It's going to give you an API call, and you can get the job done. So in this scenario, you're getting the job done ASAP, but at the same time you're also like learning through the process, right? So for both learning and like a smooth onboarding experience, especially when you have new APIs, this would be a good experience, right?
Yeah, I think maybe I stepped into it too. Like, I think still just at that high level of use. There's different like levels to the APIs, and yeah, it's so interesting. I mean, that integrations of like Weaviate and Llama Index is different from like then within Weaviate, like how does the LSM store interact with the HNSW? So yeah, yeah, it's really fascinating stuff. So, yeah, so I guess my next question then, well, yeah, so you mentioned the baby gorillas and kind of, it sounds like you also kind of share this thing. Yeah, and then gorilla, by the way, is just the best name for a paper. You got the emoji and yeah, it all. But this kind of like, yeah, like, would there be a maybe a hierarchy to gorillas? Like, like some like there's a gorilla that knows that some of these baby gorillas fit together, like particular like to stay on this Weaviate. Maybe like let's add like Cohere. Like you want to use Cohere models, Weaviate vector database, and then Llama Index client framework. So like there is maybe a gorilla that knows that these things fit together, as well as the baby gorilla specific to each thing. Does that maybe sound like how the gorilla hierarchy could play with each other?
Yeah, Connor, great question. And this is just kind of research questions that we're also trying to understand. Just like we don't have an answer yet, but it's like yeah, like, what do the interactions look like, right? Because if you're using, like you mentioned, like just Cohere for models, Llama Index for all the connectors to different data sources, or like Weaviate individually may make sense. But if you only use all three of them, then what would you need? And oh, what if I want to like use this information to then use some other set of APIs? So then who's the orchestration engine here? It's all, yeah, it's open research. We're thinking into that. And I think we touched upon a little initially where you could use a third party or like even our own LLM, which is more general purpose. Right? It just needs to know how to route it, but not necessarily how what needs to be routed. And it's, yeah, open research.
Yeah, I guess like another question I wanted to ask. So like this evolution of Gorilla, what like I forecast it could become is kind of seems similar to the promise of Hugging Face, sort of. Can you maybe tell me your perspective on Gorilla versus Hugging Face, how they're different from each other, or if yeah, or if because like I could imagine Hugging Face how they have like image classification, like all the segment, all the tasks, like API usage could become another task. But then I also think, as you mentioned, this kind of like hierarchy, like there's and then there's probably more nuance to this particular task. So yeah, how do you see that kind of like Gorilla and Hugging Face?
Yeah, I like it's also my personal view of things, Connor. It's like Hugging Face is like more like developers are mind sharing. They're sharing what model they have trained. They're sharing their like basically the how the model is performing on different various of data sets. But Gorilla is more like, in my view, a communication between the API itself. Like also another example is I think the Stanford AI tongue paper. They also recently released their open source code. So imagine if we have a ton of different, I don't know, language model agents, and then they sort of will be having some ways to talking with each other, to communicating, and to eventually to solve a task. Like, but Hugging Face, in my point of view, is like great tool for sharing your capabilities, for sharing your results. But the ultimately the people or the different models haven't been, or it might be Hugging Face are trying to do something wrong, but different models hasn't been grouped together in order to solve a task. That's my opinion. I feel like in order to solve a task, you may need some, for example, managers, engineers, and you may need some salesperson, and then this is communication between different levels of future agents or future APIs. Like have a sales API, have an engineer API, or various of like APIs. They are trying to communicate between each other, and eventually it's about task solving.
Yeah, I've loved this kind of like I think GPT team is one of these like viral GitHub projects that describes this kind of idea of like role playing GPTs. I'm the marketer, I'm the engineer, I'm the product manager, and yeah, like the way you've abstracted this into thinking about APIs has made this idea so much clearer for me, some like more tangible kind of. Uh, yeah, it's a really compelling. I love how you connected it with the like Westworld paper. I never would have made that kind of connection, but you can think of like, like I could think of Shishir as an API that I ask questions to, and yeah. So yeah. Sorry if I'm pivoting the topics kind of hard. I wanted to ask about the kind of structured output parsing. Sorry, I know this is a pivot in topics. Like people do things like look for like backtick JSON and I'm curious, like what kind of stuff goes into the Gorilla for doing that kind of making sure it follows the syntax.
Yeah, so I think this is actually a great question, Connor. What we think, or at least what we are currently thinking, Gorilla is like it's definitely not compatible with GPT-4 because GPT-4 is, or comparing to Gorilla, is like a super agent, or it's more like a general intelligence bot that can do everything. But this has good things and bad things. Good things is like it can do everything. Basically, whatever you ask ChatGPT or GPT-4, it gets you some kind of pretty good response. But one of the disadvantage of that is its output is very diverse. Like for example, if you ask it's if you just chat with them, every time usually if you don't adding a specific deterministic sampling to GPT-4, every time the output is kind of is from different structure, different content. but sort of answering your same question. It's like more like natural language. But this thing can be a little bit tricky for actually if you want to generate JSON files, for example, or if you want to generate API calls, because you need to follow the exact syntax, and also you need to get every domain correct. So what we think is like for the first thing is like fine tuning or a specialized model for this structure may help a little bit, because now the model knows I need to follow a specific structure, and I don't like also like Gorilla is doing right now. It doesn't care about maybe chatting capability right now. So it knows like here is a structure output, and I need to get the structure correct. Also, the second point is with this retrieval-aware training, you're providing some description of your output. Like the model basically reads documentation, knows what the structure should be like in their outputs. So the model should have a little bit more context about how the output is structured, and getting these things more reliably and clearly, better than, in my point of view, like a general chatbot. Although general chatbot are kind of can they do this task in a pretty good manner, I think.
Well, that's kind of that's something about the general chatbot, and then like okay, so there's this idea of reflection prompting where like I had it write a Weaviate query, it didn't execute, and I show it the error message, and it sees the error message and goes, "Oh, sorry, here's the correct one." And I worry that if you fine tune the model and compress it, you might lose the ability of it to do that kind of like reflect on the error message unless you had another model that's been specialized on the error messages.
Yeah, I think that's a great question, honestly. But I think okay, to my study of the up to date models, even GPT, even ChatGPT is not good at this reflection. Like GPT-4 is very good. It's to some extent much better than ChatGPT 3.5. Because I did actually did some of the studies on the big bench tasks. From the ChatGPT point of view, the accuracy improves from, I would say, 20% to 40% after you output the error message. But for GPT-4, it actually improves from 20% to 60 or 70%. So I would say this is a very open, like research question here on how to on even how to get models to reflect its answers, and getting the correction part based on the error message, at least for the open source models, because we don't know how OpenAI did that. But this is actually a huge research question. So one way is to imagine you have a separate model that can do this task. Another way is how you can also, in the meanwhile, not only teach the model to do this structure output, but also in adding other capabilities to the model that is crucial to your task solving. It's also something like we're kind of exploring as well.
Yeah, I think it's kind of like, well, that last thing you said about like the adding new functionality and kind of like the maintenance, the continual learning. I think it all becomes so interest. I think it becomes like uh, novel in this particular kind of task compared to most deep learning tasks, because you have like kind of like test cases like pass fail, whereas usually the generalization testing for continual learning is so abstract kind of. But yeah, I think all of that is just, yeah, really interesting how it will be able to reflect. I know there's like papers where they like they train like a code repair model where they purposely break the code and it learns those kind of differences. And yeah, all that kind of discussion is really fascinating. So awesome. So could we maybe conclude with kind of like some like what's on the horizon, like what kind of things are you guys just thinking about?
Yeah, I think one thing that we want to like explore more is this thing that we touched upon in our paper, which is hallucination, which we know that it's a big problem for LLMs. And I think with, like if you ask today, oh, how much does GPT-4 hallucinate? There's no good answer, right? There's no number as such. It's mostly people have adjectives. So we, with abstract syntax tree, we have like a clear PL based approach that you can measure hallucination. So that's something that we want to like double down and explore more and see, what can we learn from it? How well can we extend it? And then retrieval-aware training is another approach, which I think has shown a lot of promise for us with APIs. and just doubling down on that and trying and seeing how generalizable it is. Does it hold as we scale beyond what we have so far? And then besides that, I think there's just like a lot of inbound interest on what APIs do we include, and then the different modalities to like serve it. Like we initially had a collab notebook that you can talk to the model, and then a lot of people were like, "Hey, can I try it into my workflow?" So we came up with the CLI tool, and there's a spotlight that we're just doing some finishing touches on that we want to get into people's hands. But yeah, so different modalities, how people can, if you think of it, all of these are just different ways to use APIs. And once you have the pipeline behind, then you can like build this. But otherwise, yeah, we're committed to the open source project. So if people want to contribute, we'd love to have people on board. And it's like a lot of it. We're just listening to the community from our GitHub, from our Discord, and then just taking it one step at a time.
Yeah, I hope we're first Weaviate, but I do also hope this podcast inspires more people to add their APIs to this because yeah, I'm so excited to see how this kind of the APIZoo develops and all the research on what happens as you continue to scale it. Yeah, those are all really interesting questions. Tianjun, let me get your response as well on the same question of like kind of the future directions that inspire you the most.
Yeah, I think building on top or a little bit adding Shishir's point is like we have also received or a lot of the great advice from the I think either GitHub issues or the Discord communities are coming to us. So that's also kind of shapes what we are heading to some extent. But in general, I feel like this RM like agency is very interesting. But we have a lot of problem to solve to make it fully autonomous and also fully reliable, successful agent for LLMs. And a lot of them, including like long context, also memory, the memory of the previous stuff, and also tool usage, and chaining together APIs. These are like also great research and open research questions. And we kind of want to also explore how Gorilla can better support also not only the research direction into this area, but also some open source community, like whether they adopt Gorilla as a backend model or they adopt Gorilla as one component as they see moving forward in the future to building this RM agents to for task solving.
Yeah, I mean, I hope this isn't too redundant, but yeah, like that kind of long context reminds me again of that like retrieve enough API references for how to import data into Weaviate, and then retrieve enough API references for how to set up the query engine and Llama index, and then combine that into just generating, doing the whole entire task in one kind of forward pass. And yeah, and then that kind of I love that kind of thinking of like what how will it fit into the existing ecosystem because like I imagine like with the I think Llama Index calls it data agents or LangChain is really famous for this kind of agent orchestration. I think it could either just be like the future of integrations is all these things have like a language model in front of them that translates natural language into the thing, but then you also kind of have to have some description of like what you could do with like you have to be like Weaviate could do these kind of things before you even would think to formulate the question like how do I BM25 search and then re-rank with Cohere, like it would need to have some description of that. But yeah, amazing. Shishir and Tianjun, thank you so much for joining the Weaviate podcast. I think you have such an amazing project. Gorilla, one of the coolest projects I've ever seen, especially in the space of agents and large language models. It's been so much fun building this for the Weaviate APIs, and I hope people will find this interesting. And yeah, I can't wait to see where this, how this evolves.
Yeah, thank you, Connor. It's a great.
Yeah, and thank you so much, Connor, for doing this. It's always a thrill chatting with you. So looking forward to chatting again.